Hey y'all, what we're going to do now is I'm going to give you an introduction on graphing polynomials. A polynomial is a function that looks like this. Y equals some constant times x to the n plus some constant times x to the n minus 1. What we're doing is we're reducing the power of the x by 1 plus another constant x minus 2, because again we decrease the constant by 1 again. We continue doing this until we're just left with some constant. Now I'm going to put plus z because z is the end of the alphabet. However, you all know how to do this because we've just finished doing a quiz where we took x plus some constant, and we'll call it c for no other reason, and we raised it to the n. And we expanded this using Pascal's triangle and other patterns that we saw. I'm going to show you how to graph these things without doing very much work. It's really relatively simple. Check this out. I have this graph here. Well, whenever I'm given a function, and I'll do this polynomial here, x plus, well, let's say 1, and we raise it to the 1 power. Any polynomial that we have here that's going to be raised to the 1 power like this, anytime that there's a root, okay, and I'm going to write the word root, I could also write the word 0. You know, some teachers even called zeros x-intercepts. I know I have. And then, of course, we call x-intercepts roots, zeros. We also call them solutions. Well, what are those things? Well, there's wherever this crosses the x-axis. So what I mean by that is I take x plus 1 and I set it equal to 0 because I want the y value to be 0. When I solve this, x is going to equal negative 1. I want you to notice, we could do this whole solutions bit, but we could also just look at this and say, look, it's inside parentheses. I'm going to take the opposite of whatever this number is. So for instance, the opposite is negative 1. So I go on the x-axis and I graph a point at negative 1. Now, for all practical purposes, ladies and gentlemen, if it's raised to a 1 power, the line that goes through this is just going to go through it. It doesn't going to do anything special. It's just going to go through that point and, you know, kind of like, oh well, it's only raised to the 1 power. Big deal. Let me show you what happens if we change this power up here to something else. For instance, let's say I took y equals x, and this time we're going to put minus 2, and we're going to raise it to the 2 power. Well, if we were going to solve this thing, and again, I'm going to go ahead and solve it. I'll say x minus 2, and we're going to set it equal to 0, because we want to know where the y value is 0. Turns out that x equals positive 2. Oh, well, I could have just taken the opposite of that. I'm going to go to positive 2, and I'm going to put a dot. Now, unlike its linear counterpart, when you have an exponent of 2 on this polynomial like this, we're not going to just go through that point. Actually, we're going to draw a line, and when we get to that point, it's going to bounce off. Some of y'all recognize this as a parabola. Well, that's what happens whenever you get to a root or an intercept that has a squared power on it. You're going to bounce off of it, kind of in a smooth little bounce like this. Does it change for all of the exponents? It does. Let's look at what happens when you have, oh, I don't know, this time I'll put x plus 4 to the 3rd power. Without actually having to solve it, can y'all tell me right now what the x-intercept is going to be here? If you said negative 4, you're absolutely right. Because when we set the inside equal to 0, we would get negative 4. I like to say we just take the opposite, whatever inside the parentheses. Let's go to negative 4 on our x-axis. Now, because it's raised to the third power, something special happens here. We do what's called an inflection point. So in other words, when my line approaches this dot, it's going to kind of change direction a little bit. So if I would draw this a little bit better, it changes direction. Now this inflection point, it doesn't go straight through it. It kind of curves a little bit. Okay? And we call this an inflection point. Anytime something's raised to the third power, that's what's going to happen there. In the second part of this video, I will make a generalization of what happens when the powers change from even to odd.